Hey guys, welcome back to my YouTube channel. Today we are going to solve day 10 problem on LeetCode. If you haven't subscribed to my YouTube channel yet, then please go ahead and subscribe for daily content. So let's read this problem statement. So in this problem we have to calculate the amount of time for a binary tree to be infected, and here we have given the root of a binary tree with unique values and an integer start. At minute 0 an infection starts from the node with the value start. Okay, and each minute a node becomes infected if the node is currently unaffected and the node is adjacent to an infected node. Okay, and we have to return the number of minutes needed for the entire tree to be infected. So here let's see this problem. So here this is the tree given to us and the infection starts at this node 3. So at minute 0 node 3 is infected. At minute 1 node 1, 10 and 6 are infected because all these three nodes are adjacent to this node 3. So at minute 1 node 10 and node 6 are infected, and then in minute 2 this node 5 is infected. At minute 3 this node 4 is infected, and at minute 4 node 9 and 2 are infected. So it totally takes 4 minutes for the whole tree to be infected, so we return 4. Okay, so now first to solve this problem we are going to convert this tree to a graph. So how we are going to do that? So let's understand this with an example here. So this is the tree given to us and we are going to create a graph, and in this graph each key is going to contain all the adjacent nodes to it. So here let's start with this root node. Okay, let's start this root node. So everyone knows that this root node doesn't have any parent. So let's here it doesn't have any parent. Okay, so here we can treat it as 0 or nothing. Okay, so this root node doesn't have any parent, so just take a note of it. And now this one node, so both these 5 and 3 are adjacent to it. So here in map this is going to be our key, that is a current node. Okay, current node is going to be our key, and this is the hash set. This is a set where we are going to create, and in this we are going to store the values of all the adjacent nodes. So we are going to store if there is any parent, then we are going to store that value. If there is any left node to this current node, then we are going to store that value. If there is any right, then we are going to store that value. So in this way we are going to store the values. So first we are going to check for this one. So for this one both 3 and 5 are adjacent. Okay, so here 1 contains 3 and 5. So 1 is done. So now let's go to this left side. First we are going to cover the left side elements. So when we go to this left, then for this 5 there is no left, but there is one right for this 5 and one parent. So for 5 we store value as 1 and 4. Okay, so now since there is no left, we come to the right of 5. So when we come to right of 5 we encounter this 4. So now we are going to store the value of this 4. So for this 4 there is one right, there is one left, and there is one parent. So we are going to add all these values 2, 9 and 5 in the 4. Okay, so this key contains all these adjacency list. Okay, so same way now we are going to check for 9. So 9 has only one parent 4, and there is no left and right. So in this case we are just going to add 9 is equal to 4. Then we come back again. Now after that we are going to check for this 2. So there is no left and right, but only a parent is there, so we have added the value of 2 here. Okay, so once this is done we are going to get back here, this back here, and then we come to this 3. So for this 3 this is a parent value is 1, left child is 10, right child is 6. So we are going to add 1, 6, 10, 6. So in this way we have added 3. So now after that we go to this left, we are going to check for this 10. So for this 10 there is just a single parent only, and there are no left and right child. So that is why we have just added 10 is equal to 3, and in the end we are going to check for, we are going to come back and we are going to add for 6. So in this way we are going to create one map. Okay, so here we have just converted this tree to a graph. Okay, so now it's going to be very easy to solve this problem. We can use BFS or DFS, but in this problem, in this specific tutorial we are going to use BFS first, and then later on I am going to make one more tutorial which is going to solve this same problem with using DFS. So now let's see what we are going to do next. Okay. So now I am going to create one method, tree to graph. Okay, so here create one private method, private void tree to graph, and in this first pass the root node. So for that I am just going to write tree node current. So here we are going to pass first our root, and we are also going to pass the parent. So for root you already know that the parent value is 0 only, since there is no parent for this root node. So here I am going to pass the parent of a particular node, and then I am going to create one map. And in this map what we are passing, first we are passing the node value. Okay, so in this map first our key is going to be that particular node. So let's say it is an integer, and then I am going to create one set, hash set. So for this we are going to write like this, set of, this is set of integers only. Okay, so this is set of integers, so set of integers, and let's name it as map. Okay, so now in this tree to graph method, let's first check if the value of current is not null. So if the value of current is not equal to null, in that case initially this is going to be our current. So initially we are going to pass root. So if this current value is not equal to null, so it is true, then after that we are going to check that whether our map already contains this root value, this value or not. So we are going to write like this, if map dot contains key, and in this key we are going to pass what, our current dot value, current dot value. Okay, so here I have passed the current dot value, and let's close it. So here if it doesn't contain this value, if our map doesn't contains this key value, that is 1, let's say this one, if it doesn't contain, then in that case we are just going to add what, we are going to add this key into the map. So how we are going to add that particular key? So for that we are going to use map.put. Okay, and in this first we are going to pass the key, that is current dot key. Okay, and then sorry, it is going to be current dot value. Okay, and then after that here we have passed this a key, that is current dot value, and here we are going to pass our hash set. So let's create one hash set here. Let's name that hash set as we are going to create one adjacency list, so let's name it as AL. Okay, set of integer AL is equal to new hash set. Okay, and now I'm going in this map, I am first passing this key if it is not there, that is current dot value, and then I am passing the our hash set, this adjacency list. Okay, now after that, once it is done, close this, and then check now for the parent. So initially, as you know that for our parent the root value is 0. For our parent, for this root the parent value is 0, but for all other nodes like 5, the value is not going to be 0. For this value is not going to be 0 of parent. For this node value is not going to be 0 of parent because it is 5. For this node value is not going to be 0 of parent. So only for a root we have to ignore this. Okay, we have to ignore the value of parent only for root. So I can write it like this: if parent is not equal to 0. Okay, if parent is not equal to 0, then in that case I am going to just add this value into our adjacency list, al.add. Okay, al.add parent. Okay, so here for this one we are ignoring this if condition since our parent is 0 for this one, but we have the left values and right values. So let's check for the left and right values here. So if current dot left is not equal to null, then just add this al dot add value current dot left dot value. Then I have checked the left, now I am going to check for the right. So same way, simple. If current dot right is not equal to null, then in that case I am just going to add this value into our adjacency list. So current dot right dot value. Okay, so in this way we are going to add our current dot right and current dot left values. And now after that, just check here if current dot left is not equal to null, then in that case we are going to again call this tree to graph method. Tree to is capital to graph, and now here inside this I am going to pass the left node current dot left, and parent is going to be like, if I go to this value 5 current dot left for this one, so for this parent is going to be this one. Okay, so can I write it like this: current dot val from the previous step. Okay, so right now when I am in this function, so our current dot value is going to be this one, okay, which I am passing for the next step for this 5. So here I can write the parent as current dot value. Okay, and now just write map and use semicolon. Same way check for the right condition. If current dot right, here current dot right description, if current dot right is not equal to null, tree to graph is equal to current dot right and current dot val dot map. Okay, so in this way we write the code for our converting the tree to graph. So now we have obtained this. Okay, so now after that we are going to write this public int amount of time method. So in this method what we are going to do, first just check, first create this map. So just copy this. First we are going to create this map hash map integer set of integer map is equal to new hash map. And now I told you that for the root node we are going to call this method for the root node first, tree to graph, and here first I am going to pass this root, and for root the parent is going to be 0 and our map. Okay, so in this way I have called the tree to graph So right now I'm going to use BFS. Okay, I'm going to use breadth first search algorithm here for this problem. So now once you call this method, now after that just we are going to create one queue. Okay, so to create a queue you can write like this queue, and queue is going to contain the integer. Okay, like in this queue we are going to pass one by one all these elements. Okay, so queue is consisting of these nodes which are integer. So queue of integer, write here queue and new linked list, and initially in this queue we are going to start with our start, this node. So here just write queue dot add start, and now we have created one queue, and let's create one hash set, visited hash set. Okay, so here we are going to add our visited nodes set of integer and name it as visited, and here new hash set. Okay, and now in this visited also since we added this value start in the queue, so add this same in visited as well. Visited dot start, visited dot add start. Now this is int amount of time, so we have to calculate the amount of time, so it is an int format. So let's create a one variable where we are going to store our result. So int minutes is equal to 0. Okay, now run one while loop. While we are going to run this while loop if it is the queue is not empty. So here write like this, if queue dot is empty. Okay, so now while our queue is not empty, so in that case inside that we are going to get the length of queue first. Okay, int length of queue. So what is going to, how we are going to get the length of queue? Just write queue dot size. This will give the length of queue. Inside this again we are going to write one while loop. In this while loop we are going to check if the length of queue is greater than 0. Okay, and here in the while loop we are going to also decrement this, the length of queue, one every time. And now in this while loop, length, okay, and in this while loop now first let's poll this method. Let's use this. We are going to store the value of the queue using queue.poll. So what it is going to do, that it is going to retrieve the foremost element from the queue, okay, and remove that from the queue. So in this way we are going to get the current element. Okay, so means front element, it is going to take the front element from the queue, that is till now we have added only 3, so it will take that value 3 here and remove that element from the queue. Okay, so for that purpose we are going to use this poll function. Okay, int current is equal to queue.poll. Then after that run one for loop, for each loop, and for each loop it is going to all the elements. Let for 3 it is going to take all these elements. Okay, so to access these elements, can I write it like this, map dot get, the key is this current, right? So can I write like this? Yes, I can write it like this, map dot get current. And in this for loop we are going to check if visited dot contains this num. if it doesn't contain this visited, okay, then in this visited we are going to add the num, and same way in the queue also we are going to add this num. Okay, so now I have added and I am decrementing the value here. Now here, once we go to all the adjacent nodes, we are just going to increment the value of minutes by 1, and in the end I am just going to return minutes minus 1. So let's run this code. Okay, minutes spelling minutes. So all the test cases are being passed here, so let me submit the code and see. Okay, so awesome, so our solution is accepted. So now if you want to understand how this piece of code is working, so for this you can check my Medium blog. In this Medium blog you will find all the information related to this problem. So first this is the problem statement, and then the approach. So here first we are going to create a graph from this tree. So in this way we have created the map. So map's first digit is going to be the node, and this is a set which is going to consist of the adjacent nodes. So here this is the code, and you can just uncomment these lines to get more clarity. So finally, once we created this map, then I have added few more details, like this key is a particular node in the map, and the hash set consists of adjacent nodes to a particular node. And here the approach that we are using, that is BFS, and the common things that you guys should know about BFS. So all these things are here, and what is this queue.poll function, and how this queue.add element function works. So all these details are here. And then this is the function BFS algorithm that we are using here. So first initially, first we pass our start as 3, queue.add is equal to start. So initially current is 3 because we are polling. Queue.poll is equal to current 3, then visit is 13, queue is 16, then visited becomes 136, queue becomes 1610. So here all these steps are there. So to understand this code, I have added this system.out.println lines. So just go through it and you will get a clear idea on how this is working. And here in the end I have added the full code. Okay, so these are the statements that you can add to debug how this problem is working step by step. So that's all folks. If you like this video, then please press the like button, share and subscribe to my YouTube channel, and till then keep coding and keep practicing. Thank you. Bye bye.